Good morning, students. Today we are discussing about Oswald's isolation method. Okay. In previous class we are discussing second order reaction and rate of reactions and zero order reactions. So in that we are concludes that rate of reaction and influence of seconds and time and variance difference. Some other quantities we are discussed. So today we are discussing about Ostwald's isolation method. So this method is applicable for reaction involving two or more reactants. Okay, students. In that second and first order reactions, only one reactant is involved, but in that only two or more reactants. Okay, we know that example Cl2 plus H2. So what happens? 2HCl is added. So in that we can see Cl2 in presence of hydrogen to form 2HCl. Okay, this is one type of reaction. And next one, Br2. We can take Br2 bromide and H2. Okay, what happens? 2H Br. Okay, this is second reaction. And next one, next వచ్చేసేసి where should we take chlorine, bromine, iodine. Okay, iodine we can take. So what happens? 2H. Okay, these are what happens? We can take 2 moles of bromine and 2 moles of hydrogen. What happens? 2HBr, one product is formed. So in that also we can discuss this method is applicable for reaction involving two or more reactants. In the method, the experiment is carried out for a number of times. Okay, we can take number of times. So in the so in this we can take what happens in this method. The two or more experiments is carried out for a number of times. Okay, what happens means okay, we can take Br2 plus H2, so 2HBr. So this experiment makes number of times. We can repeat number of times. What happens means number of times, each time taking all the reactants. What in this Br2 and H2 are reactants. Each time we can take a reactants. Okay, so we can take reactants except one in the excess turn by turn. Okay, excess turn by turn. The reactant which is not taken in excess is said to be isolated. Isolated means the reactant which is formed on side by side, that is isolated. The kinetics of the reaction theory gives the order of the reaction with respect to isolated reactant. Okay, the orders for the different reactants are added. Okay, up to get over all order of the reaction. Okay, so consider a reaction involving three reactants X, Y, Z. Okay, X, we can take X, Y, Z in this type, same like this. Okay, X, Y, Z, three reactants X, Y, Z. Further, let the order of reaction be N. When X is isolated, so N2 and Y is isolated, and N3 and Z is isolated. Overall order of the reaction will be N1 plus N2 plus N3. Okay, N1 plus N2 plus N3. Okay, students, what happens in this means this is X, Y, Z. In this reactants we can take what happens side to side. So first reaction we can take N1, and the second reaction we can take N2, third reaction N3. So total reactants we can take the total reaction. What happens? N1 plus N2 plus N3, the sum of total reactant. This is what happens Ostwald's isolation method. This diagram is in this first two reactants we can take X and Y axis. In this Cl2, this H2, and next reactant we can take H2 Cl2. In this product is formed HCl. We can take HCl. This H2 and Cl2 combine to form HCl. Okay, this is the isolation method. Okay, students, got it? What happens? Total in this method, the experiment is carried out for a number of times, each time taking all the reactants except one in excess turn by turn. The reactant which is not taken in excess is said to be isolated. The kinetics of the reactants then gives the order of the reaction. Okay, with respect to isolated reactants, the orders for the different reactants are added up to get over all the order of the reaction. Consider a reaction involving three reactants X, Y, Z. Further, let the order of the reaction be N, where X is isolated, N2 is Y is isolated, and N3 is Z is isolated. Overall order of reactions will be N1 plus N2 plus N3. Got it, students? This is the Ostwald's isolation method. Okay. Next one. This is transition state theory. Okay, this is the very important, students, for exam point of view we have discussed. So in this, according to this theory, the reactant molecules are not directly gives rise to the products, but they are first transformed an intermediate energy rich activated complex or transition state having only a transient existence. The activated complex subsequently break up to produce the products. What happens means, according to this theory, the reactant molecules are not directly gives rise to products. Okay, what happens? Reactant means these are Br2H2, these are reactants, are not directly to give rise to products. Okay, these reactants are not give rise to directly products. Why? Because but they are first transform an intermediate energy. Okay, what happened means, in this arrow mark one intermediate energy is formed. Okay, intermediate energy rich activated complex or transition state having only a transparent existence. The activated complex subsequently breaks up to procedure. Okay, what happened? The activated complex subsequently breaks up to produce the products. The rate of decomposition of the activated complex determines the rate of reaction. Okay, in this what happens? Reactants gives us to activating complex, reactions to products. Yeah, previous also we have discussed what happens. The reactants which are formed are does not directly form the products. In this intermediate molecules, one is activated, so that is activation complex. Okay, what happen? What is transition state theory? According to this theory, the rate of molecules are not directly gives rise to the products, but they are first transformed an intermediate energy rich activated complex or transition state having only a transparent existence. The activated complex subsequently breaks up to produce the products. The rate of decomposition of the activated complex determines the rate of reaction. Okay, that is the transition state theory. So in this, reactants gives rise to activation complex, gives rise to products. Okay, this example what we are taken, HA. Okay, this H2 plus I2 is there, so that is Bridges cell also the HA plus HA. So to give rise to HI, this is the square activated complex. Yeah, students, we are taking HA plus HA. This all we will take this also, H2 plus I2. Okay, we can take in this form also, but we can take we conveniently write this. Okay, HA. So what happens? HI. This is square. This is a called activated complex. So in this activated complex, we can turn HI. Okay, this is the H2I2. Okay, this is H2I2 or 2HA. Okay, So in this diagram we can take, this is energy diagram. Okay, first this is reactance. First we are taking reactance. In this reactance what happens, this peak is gradually increases. Okay, this increases because this gives rise to, okay, and what happens, gradually decreases. Why? Because this reactance has more energy. When we didn't take what happens means, uh, when we are taking freshly reactants, so they have more energy, but we can convert in products. So what happens means, in that reactants one some substances is there, so that substances are goes outside. So what happens, for example we can take mm, so for example what we are taking means, yeah, one duster, okay, board duster. So in the board duster we can take we can put, we could put in water. What happens, the dust is absorbs water molecules. So in this water molecules we cannot put any side, so we can lift the water a sponge. So what happens, they have heavy weight, but we can rub the board or rub the wall, otherwise we can put on outside. So what happens, some water molecules are goes outside, so duster weight is lost. Same like this, we can take reactants. What happens, they have freshly taken, so they have more energy. But in presence of any reactants or any intermediates, what happens, they have they lost their energy. So that's why the reactants, when we are participated, they are gradually increases, but in that products gradually decreases. So in this middle part means this activated complex. So activation energy of reactants and activation energy of products. So this is reactants, this is products. Why? Because we can take reactions. So this side only reactants, this is products, so this is only products. So this is the transition state theory of energy. So this is very important, students. According to this theory, what happens, the reactant molecules are not directly gives rise to products. Okay, what happens, ఎప్పుడైనా రియాక్టెంట్ మాలిక్యూల్స్ అనేవి ప్రొడక్ట్స్గా డైరెక్ట్గా ప్రొడక్ట్స్గా కన్వర్ట్ కావు. ఎందుకు? బట్ దే ఆర్ ఫస్ట్ ట్రాన్స్ఫార్మ్స్ అండ్ ఇంటర్మీడియట్ ఎనర్జీ రిచ్ యాక్టివేటెడ్ ఎనర్జీ ఆర్ ట్రాన్సిషన్ స్టేట్ హ్యావింగ్ ఓన్లీ ఏ ట్రాన్స్పరెంట్ ఎగ్జిస్టెన్స్. వాట్ హ్యాపెన్స్, they have only they have own their energy, and they have వాటికి ఒక ఎనర్జీ గెయిన్ చేసుకునే ఎనర్జీ ఉంటుంది. సో బ్రేక్స్ అప్ టు ప్రొడ్యూస్ ద ప్రొడక్ట్స్. మనం తీసుకునే ఇంటర్మీడియట్, ఇప్పుడు ఒక ఇంటర్మీడియట్ తీసుకున్నాం, దాన్ని బ్రేక్ చేసేసి దానిలో నుంచి ఎనర్జీని ఇంటర్మీడియట్తో పంపి చేంజ్ చేస్తే అవి లాస్ అవుతాయి. ఎనర్జీని లాస్ అయిన తర్వాత ప్రొడక్ట్ ఫామ్ అవుతాయి. ఇప్పుడు ఒక రెండు ఫర్ ఎగ్జాంపుల్ we can take electron and positive energy and negative energy. When we are taking only negative energy, we could not find any current and some other. Only positive energy, we could not find any energy. But we are taking two electron and negative charge and positive charge at a time. So we have power and power generation and energy like this comes. So same like this, only we have to take reactants. No intermediate is product is not there, intermediate product is not there, so we could not do anything. So any intermediate product is there, so we can do anything. So reactants in presence of activation complex, what happens, product is formed. So this is HI and HI. So to form HI, so HI, okay, this diagram, energy diagram. So log, this values gradually decreases. Why? Because when energy increases, log values of energy decreases. Okay, this is a product reactants, activation energy of reactants and activation energy of products. So this activated complex, okay. These are the topic. So in this, what happens from the above figure, it is clear that, so what happens, the initial stage there is a small fall in potential energy of the reactants. This is viewed to the due to the approach of the reactants molecules close to one another before reacting to form the activated complex. What happens means, on that diagram we can take, first we took reactants. So in that reactants, the energy diagram of the reactants are gradually decreases. Why? Because activation energy molecules are present in that reactants, so that's why gradually decreases. In this also the potential energy of the reactants, this is due to approach of the reactants molecules close to one another before reacting to form the activated complex. ఎప్పుడైతే రియాక్టెంట్ మాలిక్యూల్స్ అనేవి యాక్టివేటెడ్ కాంప్లెక్స్తో రియాక్ట్ చెందవో అప్పటి వరకు కూడా రియాక్టెంట్స్గానే ఉంటాయి. ఎప్పుడైతే రియాక్టెంట్స్ యాక్టివేటెడ్ కాంప్లెక్స్తో రియాక్ట్ చెందుతాయో అప్పుడు ఏమైతే ప్రొడక్ట్స్గా స్టార్ట్ అవుతాయి. సో similarly, in the final stage, there is a small rise in energy of the products, which is due to falling apart of the product molecules after the reaction. The product possesses higher energy than the reactants. The reaction will be endothermic. Okay, that is endothermic. We have to take endothermic and exothermic. Endothermic means outside the energy. Exothermic means inside the energy. So in such reaction, the activation energy of the back reaction will be always less than that of formed reaction. Okay, what happens? The activation in such reaction, the activation energy of the back reaction means back titrations and zero titrations, we know that. So back titration means one reactant is always present, but another reactions we can take another reactions due to the some reasons. So that is back titration. So back reaction will always be the less than the forward reaction. Activation energy of back reaction means that additional means one reactant present and product present, but we have take more energy, so that's why we can take additional reaction. Okay, which is a product to molecules must activate to form activated molecule. That is a transition. What happens when from the above figure, it is clear that the initial stage there is a small fall in the potential energy of the reactants. This is viewed due to the approach of the reactants molecules close to one another before reacting to form the activated complex. Okay, similarly, in the final stage there is a small rise in energy of the products, which is due to falling apart of the product molecules after the reaction. The product possesses higher energy, okay, than the reactants. The reaction will be endothermic. In such reactions, the activation energy of the back reaction will always be less than that of formed forward reaction. Okay, activation energy of a back reaction means the additional energy which is product molecules must activate to form activated molecules. Okay, this is transition state theory, and in this transition state theory, students we are only రిమెంబర్ వన్ పాయింట్ ఓన్లీ. సో ఎప్పుడైతే రియాక్టెంట్ మాలిక్యూల్స్ అనేవి డైరెక్ట్గా ప్రొడక్ట్స్గా కన్వర్ట్ కావు ఇన్ ట్రాన్సిషన్ స్టేట్, అన్ని స్టేట్స్లో కాదు, ఓన్లీ ట్రాన్సిషన్ స్టేట్ థియరీలోనే ఒక క్రిటిక్ ఏంటిది, అది రియాక్ట్స్ అనేవి ఏవి కూడా ప్రొడక్ట్స్గా డైరెక్ట్గా కన్వర్ట్ కావు. ఏమైతే యాక్టివేటెడ్ మాలిక్యూల్ అనేది ఇంటర్మీడియట్ మాలిక్యూల్ అనేది ప్రజెంట్ అయ్యింది, దాన్ని యాక్టివేషన్ ఎనర్జీ అంటాం. ఆ యాక్టివేషన్ ఎనర్జీ ప్రజెంట్ అయితేనే మనకి ట్రాన్సిషన్ స్టేట్ థియరీ స్టార్ట్ అయింది, లేకపోతే అది స్టార్ట్ కాదు. సో ఫస్ట్ వీ కెన్ టేక్ reactants. That reactants is in presence of activation molecules, so to form products. In this products, what happens, we can take reactants, two reactants, but in that activation molecules present, so two reactants combine to form one product only. Okay, in that four reactants we can two products only. So in that products, H2O molecule is not there, and H2O molecules are not participated in transition state therapy. Why? Because in the H2O molecule, H plus and OH minus molecules are there, so that's why we are taking like that. So in this collision theory, the chemical reactions occurs only when the molecule collide with each other. Okay, and what happens when molecules means CaCO3, MgSO4, and CuSO4, like that. CaCO3 means calcium carbonate and magnesium sulfate and copper sulfate. Okay, like that. So in this, what happens, the chemical reactions occurs only when the molecule collide with each other. So we can take CaCO3 plus MgSO4 plus MgC to form MgCl or CuCl. What happens? MgCl plus CuSO4. Okay, this Mg comes under the Cl, and Cl comes to this SO4. What happens? These two molecules bombard. Bombard means when molecules bombard or match with some molecules, so that collision will occur. So in this, molecules, two molecules can collide with each other. Collide means bombardment. Bombard means hitting, large hitting. So that hitting to form one molecule, MgCl, magnesium chloride, and CuSO4, copper sulfate. These two molecules are formed. Before collision, the two molecules are MgSO4 and CuCl. After collision, the molecules are converted to MgCl and CuO4. So in this, consider a reaction between two reactants, A and B. Okay, Na and Nb being the number of molecules per unit volume of A and B. And the total number of collisions per unit number of reactants will be given by Z equal to V Na Nb. Okay, this equation is Z equal to V Na Nb. Okay, this Na means number of reactants for A, this Nb means number of reactants in B. So this total comes to form collision. Okay, what happens? Collision. This is the collision theory. What happens when we take one reactant? Okay, one reactant A or one reactant A and other reactant B. So this A to form Na and B to form Nb. So those two are combined to form Z equal to total number. Z means total, equal to V Na, V per volume of Na Nb. This is the total number of A and B. Okay, V is constant. Why? Because V means value. So this value is constant. So in case each collision results in chemical reaction, then the rate constant of the reaction is obtained by dividing the number of collisions by the product of the concentration. What happens in case, okay, in వేరే కేసులో ఏమైంది, ఈచ్ కొలిజన్ results in chemical reaction. Each collision results in chemical reaction means we know that chemical reactions, this is the chemical reaction, this is also one of the chemical reaction, MgSO4 CuCl. What happens, MgCl and SO4 CuSO4. MgCl are one of the chemical reactions, CuSO4 also one of the chemical reaction. These two chemical reactions, when two reactants in presence of collision theory to form two chemical reactions. So in this, then the rate constant of the reaction is obtained by dividing the number of collisions by the product of the concentration. Means what happens, K equal to Z1 by Na and B equal to V, total E equal to value. So K means constant, okay, K equal to Z1 by Na and B. We know that Na and B, where it from reactants. We took reactants in previous case, so Na and B are formed. Z means, we know that Z, where total number of reactions by product of the two reactants, this total equal to value. This is the equation, K equal to Z by Na and B equal to V. This is the equation, okay. This is the equation, Z1 by Na and B equal to V. So Z1 means total number, and Na and B means total number of reactants in A and total number of reactants in B. So these two are combined to form product Na and B equal to total. This Z1 by Na and B equal to V. V means value, okay. So the number of collisions between the two reactants of any given concentration and temperature can be determined from the kinetic theory of gases. ఏమంటున్నాడు, the number of collisions between the two reactants means we know that MgSO4 and CuCl, the two reactants, okay. Any given concentration and temperature can be determined. Temperature and concentration, where it comes. So temperature means when we take reactants means concentrations, reactants, MgSO4 and CuCl, and then it kept in one bowl and heat with water. So what happens in that, we can do 40 degrees Celsius, 50 degrees Celsius. This is the temperatures. So in these temperatures, where it water melting point 100 degrees Celsius. Okay, this is 100 degrees Celsius. Temperature can be determined from the kinetic theory of gases. Kinetic theory of gases we were discussed in previous class also. Kinetic theory of gases. So real gas constant PRT by 100 or nRT by 100. Okay, this is the real gas constant, nRT by 100. This is the real gas constant. Okay, rate, temperature and the number of moles by 100. So this is the real gas constant. This equal to the collision theory. Okay, however, the values of K obtained by the K means K equal Z1 by Na and B. So values of K obtained by the above. Okay, on the basis of KT of gases, there are n moles per cc of the reactants. Okay, n moles per cc. The total number of colliding particles per cc per second will be given by cubic centimeter. Cc means cubic centimeter. In bikes also 150 cc, 125 cc, 220 cc and 350 cc means cubic per centimeter. Okay, this is a cubic centimeter per second. Okay, will be given. What's that equation? Z equal to rho equal to number of activated molecules by number of molecules. Okay, Q equal to N1 by N. Okay, so equation means e power minus A by RT. Okay, this is the equation. What happens, Z Z, where we taken Z from CC, colliding particles, Z equal to root 2 pi V sigma square n square. Sigma is constant and pi also constant. V means value, n means number of moles. So Q equal to number of activated molecules by number of molecules. Okay, Q equal to n1 by n1 by n number of moles per first reactant and the second reactant. Okay, number of moles per first reactant, number of moles per second reactant. So what happens? Equation e power minus Ea by RT. Okay, this is the equation. This is, and next one, this is the collision theory. And next topic is so in the total physical chemistry is was closed, right? So next one, in organic chemistry, few more topics are there. So we will discuss one topic in that one topic. So in the without the pyramids and some other. So in the so in this aromaticity of pyridine. Okay, in pyridine there are 5 zinc atoms and 1 nitrogen atom, which are all sp2 hybridized. Why means in benzene also, for example, in benzene, this is the benzene structure, we know that. So in this double bond attached with this double bond attached to 246. So what happens in the particular only single bonds present, then we will take sp3 hybridization. Otherwise in the double bond is there. In the double bond is there. This double bond includes this. This double bond includes this. So connects this. So what happens? sp2. Like that, pyridine also same like this. This okay. This is okay, pyridine. So what happens? This is also sp2. 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 Why? Because in that also double bonds are present. Double bonds in any atoms, the double bond is present. So in that benzene ring, we have to take only sp2 hybridization. No need to take sp3. Okay, we know that reaction. Okay, and this is the reaction. Okay, sp2. Okay, in the what happens? Which all are sp2 hybridized and this is its sp2 hybrid orbitals in making 2nc bonds, and the third hybrid orbital carries a of the p hybridized orbital carries the p orbital of n atom carries a single electron. Similarly, the p orbital of each C atom carries a single electron. The p orbital of n lies in the same plane as the p orbital of 5c orbital, overlap with each other, resulting in the delocalization of 6 pi electrons in the cyclic ring system. 6 pi electrons means in this pyridine 1, 2, 3. So this is also 1 pi electron. This is also 1 pi. This one. Total how much? 6. Okay, 6 pi electrons. Delocalization of electrons is called what? Delocalization of electrons. What's that? Resonance. Okay, what we call resonance. delocalization of electrons is called resonance. Okay, this is a resonance. Now, LP of electrons and N does not participate in delocalization of because the hybrid orbital of electrons carrying the lone pairs of electrons is orthogonal to the plane of p orbital of C. Okay, in this we discuss in this three lone pairs is there. Okay, in that lone pairs we have one lone pair is there, this three pi bonds is there. So in this lone pair first convert to this side. Okay, in the this side what happens, okay, we will take this also, this lone pair convert to this side. What happens, this pi bond convert to this. Okay, this is okay, in this lone pair when lone pair is gone, so there must be negative charges came to the n atom. Okay, why? Because this lone pair have positive electrons. In that positive electrons, when we take positive electrons, we will remove positive electrons. What happens? Negative atom is present in this n atom. Okay, in this n atom, so this negative atom is converted to this side. What happens? This is converted to this side. This is so. This is the pyrite. Okay. So in this electrophilic substitution reactions is there. Attack of electrons at C2. C2 position means where C2 position? This is the C2 position. In this C2 position, what happens? In this double bond is gone. So double bond is shifting of electrons. So in this C2 position, electrons is present. What happens? Unstable. Why? Because the lone pair is present in an atom. The beside the electrons is present, so the lone pair attracts the electrons, so the atom is not stable in that position. Okay, next one, attack of E plus at C3. సేమ్ లైక్ దిస్ డిలోకలైజేషన్ జరుగుతాయి లోపల మొత్తం బాండ్స్ అనేవి. డిలోకలైజేషన్ జరిగినప్పుడు ఎక్కడ అటాక్ కావాలి? అటాక్ ఆఫ్ ఎలక్ట్రాన్స్ ఎట్ C3 పొజిషన్లో ఎలక్ట్రాన్స్ అటాక్ కావాలి. ఎలక్ట్రాన్స్ అటాక్ అయిన తర్వాత ఏమైతే దిస్ డిలోకలైజేషన్ జరిగిన తర్వాత దిస్ ఈజ్ స్టేబుల్. వై? బికాస్ దిస్ ఈజ్ ఎన్ ఆటమ్, ఎలక్ట్రోనెగటివ్ ఆటమ్. సో దిస్ ఎన్ ఆటమ్ ఈజ్ ఫార్ ఫ్రమ్ electrons. So when attracts the electrons doesn't come. Why? Because they are far from that. Okay, that's why they can't come. Next one, attack of electrons at C4 position. C4 position is opposite position also we can't do anything, because the electron is in first position, the electronegative atom is first position, the electrons are fourth position. So when electronegative atom go to first position, second position, and third position, fourth position. In this fourth position, the electronegative atom has loses their energy and keep going on. So they lose their energy and they can't do anything from electrons. So that's why this is far from the electronegative atom. So this is a electronic substitution reaction. This is also very important. So students, this is 3R. First one, attack of E plus at C2, attack of E plus at C3, attack of E plus at C4. C2 position lo emaidi, they are near to the electronegative atom, so unstable. This is a small force, so stable. This is also very stable. Okay, this is the class.